Good day, guys. Today I'm going to deal with mesh analysis, and this will be our circuit, the one that I'm gonna deal with today. Okay, so we are given a potential difference of 30 volts. Right here, we are given this configuration. As you can see, this is a kind of back-to-back delta connection. Okay. Yeah, and if you like, you can rearrange these resistors into a form that makes sense to you. Okay, that is possible, but I'm gonna use them as they are. Okay, we are further given this current that goes to that direction is I1, and we are given the current that goes through here as I2. Then we are given the current that goes through 20 ohm resistor. Let me shift the circuit a little bit. Since this is I1, this is I2, this is I1 minus I2, because when it reaches this point, the current split. Okay, now when it reaches this point, we're gonna have a new current that goes to this direction, and another one will go to that direction. So the current that goes to this 30 ohm resistor, it's I3. Okay, then let me shift this a little bit. Yeah. Then we have another current that goes to here, goes through this resistor. We have I2, we have I3. So the current that goes through a 40 ohm resistor, it's a I2 minus I3, I2 minus I3. Okay, so now I1 minus I2 comes to this direction, and then I3 goes to this direction. So the current that goes to that direction is I1 minus I2, this current. Remember, this is one current plus I3. Okay, so as long as you can understand what's happening with this current, you got it right. Okay, now I am purposefully going to take the opposite direction of this current, so that you can see when you calculate why sometimes do you get negative values. Okay, yes, I don't want people to inbox me on YouTube saying, no, you made a mistake, I tried to simulate this current. No, purposefully I'm gonna make sure that I get a negative I get a positive answer, for example, if the answer is negative, or get the negative answer if the answer is positive. You understand? Okay, fine. Now let's get to it. So what do we do now? You deal with meshes or a loop, for example. I'm going to start with this one, the outer loop, and create an equation for that. So the equation for the outmost loop will be it will be 30 for the potential difference minus 10 I1. Okay, why am I minusing 10 I1? Let me show you. Okay, okay, why am I going to minus 10? Wait a minute. I have no. Here it's not I1, this is I2. Okay, sorry, it's a mistake. Minus 10 I2, this is I2, just that I assigned this one as I1, hence I made a mistake. Okay, so it's 30 minus 10 I2. Okay, Now we're on this point, minus 40 into I2 minus I3. If you can check, this current goes to the direction of this current, but I said minus. That is the cause of the opposite sign that I'm gonna get at the end of the question. Okay, fine, let me not confuse you, let me continue. So I have this equation equal to 0. Now let us simplify it, group the like terms and simplify it. So I'm gonna take everything to the other side. So, or yeah, I'm just gonna open this bracket. This is 40, not 4, because of this resistor. So minus 10 plus minus 40 times I2, I'm gonna have minus 50 I2, then minus 40 I3, which is equals to minus 30. Okay, now I'm gonna no, minus 40 minus 30, it's gonna be positive. Okay, it's gonna be positive. Then I'm gonna multiply everything by -1, just to make my constant there as a positive. So I'm going to have 50 I2 plus 40 I3 equals to 30. This will be negative. Forgive me for that, I have an eraser. Okay, this will be negative. So I'm going to label this as equation 1. This will be my equation 1. Okay, now we're going to look at the second mesh, or the second loop. I'm going to use this one as the second loop. Okay, so bear in mind the question says calculate the current that passes through the 30 ohm resistor. Basically they want I3. Okay, fine. Now the equation for this one will be minus 20 multiplied by this, minus 20 multiplied by this. Then when I go to this direction, since it goes to the opposite direction, I'm gonna add, because when it goes to the same direction I was subtracting, né? And then this one I'm gonna add it to, because it goes to the opposite direction. Okay, fine. I'm going to write my second equation right now. It will be minus 20 I1. Okay, let me not open the bracket right now, because I want you to see where the equations are coming from. Okay, minus 20 into I1 minus I2, that is the current that goes through that 20 ohm resistor. Okay, plus 30 I3 plus 10 I2 equals to 0. Okay, now I'm rearranging and adding the like terms. Alright, so when I rearrange and add the like terms, I'm gonna have minus 20 I1, then I'm gonna have plus 30 I2, then plus 30 I3 equals to 0. I hope you guys are following, because positive 10 Negative 20 times negative 1 will be positive 20. They will add up to 30. This one just didn't change. Okay, so this will be my equation 2. Okay, now to get our equation 3, we're going to use this loop or the mesh, depends which vocabulary you want to use. Okay, fine. Now I'm going to have 25 multiplied by all this, but since it goes to the same direction as this current, I'm gonna put negative. Remember, I want to get an opposite answer purposefully. Okay, then here I'm going to make plus 40 times this, minus I3 multiplied by that. Okay, so let us write the equation for the third loop. The equation for the third loop will be minus 25 into I2, it's I1 minus I2 plus I3, and then plus 40 into I2 minus I3 minus 30 I3, then they will all equal to 0. Then right now I need to simplify my equation, so when I write it in the simplest form, I'm going to have minus 25, so positive 25 of I2 plus positive 40 of I2 is positive 65 of I2. Okay, so I'm going to have positive 65 I2. Then for I3 I'm going to have negative 25 minus 40, so it's minus in total minus 65 minus 30, so it's minus 95. Okay, minus 95 I3 equal to 0. So this one becomes my equation 3. So you take this this is supposed to be I1. Okay, so now you take this as your third equation, you take this as your second equation, then you're gonna take this as your first equation. Now you are going to punch it on your calculator. You can solve this thing algebraically using simultaneous equation, but wow, that's gonna take me forever. Okay, so when you use your calculator, you are going to get you are going to get I1 is equals to 1,303 ampere, I2 is equals to 0,7 amperes, then I3 you are going to get 1,49 milliamperes. This is equivalent to milli 1, 2, 3. This is equivalent to 0,149 amperes. Okay, so this is the required current, because they said current through 10 ohm resistor, and I3 is the current through our 30 ohm resistor, not 10 ohm. They wanted the current that passes there. Okay, so please just like the video, comment and subscribe to the channel. By the way, I'm a tutor for electrical engineering modules. If you want assistance, you can contact me. Yes, just try to contact me. Okay, cheers guys.